All right, let's jump right in. If you've ever written any code, you know that functions and methods are like the absolute foundation for keeping things organized and efficient. Seriously, they're the building blocks that turn a jumbled mess of a script into clean, powerful, and reusable code. So today, we're going to break down exactly how they work in Java. So here's the game plan. We're going to start with a problem every single coder faces, repeating yourself over and over. Then we'll introduce the solution, Java methods, and see how they shuttle data around. We'll even tackle a really tricky concept that trips up a lot of people, add a few more powerful tools to our collection, and then see how it all comes together in a real-world example.
So let's picture this. You've got a simple task you need your program to do, but you need to do it a lot. This is usually where we all start, and it's where the real pain of copy and paste programming begins.
Let's say our job is super simple. Just take two numbers, add them together, and print the result. In code, it's just a couple of lines. Easy enough, right?
But what happens when you need to do it again, somewhere else in your code? Well, the most obvious thing to do seems to be you just copy that little block of code and paste it where you need it. Problem solved. For now. And then you need it again and again. Now, just imagine doing this 100 times. What if you realize you made a tiny mistake in the logic? You'd have to hunt down and fix every single copy. It's slow, it's a total nightmare to update, and it's just asking for bugs.
Oh, for sure. There is a much, much better way. And it leads us to one of the most important principles in all of programming. And that solution is the method. You can think of methods as Java's brilliant answer to the problem of repetitive code. They let us wrap up a specific task, give it a name, and then call on it whenever we want. This whole idea boils down to something called the dry principle. Don't repeat yourself. Instead of copying and pasting code all over the place, you write it just once, stick it inside a method, and then you can reuse that single reliable block of code as many times as you need.
So what exactly is a method? Well, it's really just a named block of code that's built to do one particular thing. And the key is, it only runs when you explicitly call it. And, in the world of Java, since pretty much everything lives inside a class, we just call these functions methods. Same idea, different name. Okay, let's break down how you actually build one. First, you have the access modifier. That basically controls who's allowed to use this method. Next up is the return type, which is what the method gives you back when it's done, if anything. Then you've got the method name itself. That's how you call it. And finally, you have the parameters in parentheses. These are the inputs, the information the method needs to do its job. So we have this nice, self-contained little package of code. But how do we actually get information into it, and how do we get an answer out of it? Well, that's where parameters and return types really shine.
You can think of methods as coming in two main flavors. On the left, you've got your void methods. These are like workers you give a command to. They go off and do a job, like printing something to the screen, but they don't report back with a result. On the right, though, you have methods with a return type. These are the ones that do a calculation and then hand you back a result, a value that you can actually catch and use later on in your code.
And the most important part of getting a value back is that return keyword. Because as one of my favorite developers likes to say, the moment your code hits a return statement, that's it. The function is over. It's done. Nothing after that line of code is going to run. The method has said its final piece, and it's out.
All right, now we need to talk about one of the biggest hurdles for anyone learning Java. Seriously, this one concept causes so much confusion, and it's all about what's really going on when you pass your data into a method.
So let's look at a classic programming puzzle. Say you have two variables, A and B. You pass them into a method that's supposed to swap their values, but when the method is finished and you go and check A and B back in your main code, they haven't changed at all. What is going on?
And here it is, the big answer. This is a fundamental rule in Java you just have to burn into your memory. Java is always passed by value. What that means is when you pass a variable to a method, you are not handing over the original variable. You're giving the method a photocopy. The method can do whatever it wants to that copy, scribble on it, tear it up, but the original is back in your code, perfectly safe and untouched.
This table really breaks it down. Let's look at the top row for simple things, primitives, like a number. What gets passed? A copy of the value itself. So, can the original be changed? Nope, not a chance. But now look at the bottom row for objects like an array. This is where it gets tricky. What gets passed is a copy of the reference, basically a copy of the memory address that points to the object. So both the original reference and the method's copy are pointing to the exact same object. This means that while you can't change the original reference itself, you can follow that path and change the contents of the original object. That's why changes to an array inside a method actually stick. Okay, Once you get the hang of those core ideas, there are a few more really powerful tools that are related to methods that can make your code even cleaner and more flexible.
Let's just quickly touch on 3 of them. First up is scope. The easiest way to think about this is that a method is like a sealed box. Any variables you create inside that box stay inside that box. You can't see them or use them from the outside. Next is method overloading. This is cool. It lets you create multiple methods that have the exact same name, as long as they take in different inputs or parameters. It's kind of like having one tool name that can handle different jobs. And finally, there's var_x. This is a super handy feature that lets you design a method that can accept any number of arguments, making it incredibly flexible.
All right, that's enough theory. Let's actually see how all these pieces fit together to take a problem that could be pretty complicated and make it beautifully simple.
Check this out. The task of figuring out if a number is a prime number, that logic can get a little messy. But by tucking all of that complexity away inside a single method, like this isPrime method, we've created a simple, reusable black box. We just feed it a number, and it gives us back a clear, simple yes or no. We don't have to care about how it works every single time we use it. We just trust that it does. And that right there is the real magic of methods, hiding complexity.
And that's really the big takeaway here. It often just takes one. One well-designed method can take a complicated idea, get rid of repetition, and make your entire program so much easier to read and to maintain.
So you see, methods aren't just a feature of the Java language. They're a whole way of thinking. They're the blueprint for turning messy, complicated code into clean, elegant solutions. It's all about learning to see big problems and break them down into smaller, manageable pieces. You have the blueprint now, so what are you going to build?